class. We're in our second unit in Chapter 3, Section 4, which is equations of lines. If you remember, we covered equations of lines extensively last year in algebra, so we're going to jump right into it. Our objectives today are to write an equation of a line given information about the graph, and then to also solve problems by writing equations. So our first one we're going to talk about is a very familiar one. It's our slope-intercept. Remember that M represents our slope, and B represents our y-intercept. So if we look, we have the graph of the line y equals 1/2 x plus 3 is given. And that is the graph, the equation for the graph that we have here. So if we notice, our y-intercept is up here at 3, and then our slope is up 1 and over 2 to get to the next point. And that works for any point. So here, up 1 and over 2. And if I go up here, we go up 1 and over 2. That's going to give us our next point on our lines. So if we remember, the y-intercept for any graph is where the line crosses the y-axis. So in this case, it is 3. The x-intercept for any graph is where the line crosses the x-axis. And so if we look here in this picture, that is going to be over at -6 because we're going to the left 6. All right. So let's jump right into our first problem. It says write an equation of the line with a slope of 3 and a y-intercept of -2. Then graph the lines. So in the box are some little directions to help us through this. And we're going to put y equals for our equation. First is my slope, which was 3, x plus my b, which is -2. If you'd like to, you could also write this equation as y equals 3x minus 2. Both of those equations are going to do the same thing for us. Okay, step 2 says plot the y-intercept. So we're going to go down 2 because it's a -2. And then we're going to do our slope. Our slope is 3, but we want to think of it in a rise over run. And so it's 3 over 1. So I'm going to go up 3, 1, 2, 3, and over 1. And that's where I'm going to plot my next point. And I can follow this trend up 3 and over 1, up 3 and over 1, and up 3 and over 1 to find more points on my graph. We can also keep in mind that with positives and negatives, if I made this -3 over -1, with fractions, 2 negatives are going to change into a positive. So I can keep that in mind, and I can go down 3, 1, 2, 3, and to the left 1. Those are my negatives I'm throwing in there, and can continue down 3 and over 1 until I run out of space on my graph. That's just going to extend my line, so in both directions. I like to keep my graphs going as long as I have space on my coordinate plane. Okay, my lines aren't going to be the straightest. Yours probably aren't either, but the one thing I do expect out of you is that you do put arrows on each end, because as we know, lines extend on indefinitely. All right, so next let's look at writing the equation of the line with a slope of -3/4, and it passes through the point -4, 5. Then we're expected to graph the line. Now if we notice here, this one is slightly different than our last problem because instead of a y-intercept, we are given a point. So let's first use the given information to write our y equals mx plus b equation. So y equals -3/4, and then we're going to put in our x. You can do it in parentheses, you can do it without, plus b. And here we don't have a y-intercept, so we are missing that. So we're missing our y-intercept, or our b. So to find the y-intercept, we're going to plug in the x and y value from the ordered pair and given, and then solve the problem. So here's my x and my y. So we're going to go ahead and plug 5 in for y, -3/4, and in for x goes -4 plus b. 5 is going to remain 5 right now. -3/4 times -4. If you punch that into your calculator, you're going to get a +3 because we're taking negative times a negative. And then plus b. So if we solve for b by minusing 3, we find our b is 2. So our equation looks like y equals -3/4 x plus 2. And so that's step 4. Now we had all our needed information, so we could plug it in there. So last is plot the y-intercept, use the slope, and to find the next points. So for our line here, we're going to go up 2 and make a point. And then now we have -3, so we're going to go down 3 and over 4. And I'm going to do that again, down 3 and over 4. Remember, we can change to the negative from the top to the bottom, and now that changes our slope to up 3 and to the left 4. Again, up 3 and to the left 4. This just gives us more points for our graph. So draw your line. Don't forget those arrows. Right, now let's talk about writing the equation of the line that passes through the points 0, 3, and -2, -1. Then we're going to graph the line. So here, now we are not given a slope, but we do have 2 points. So we know from our 3.3 lesson that we can find that using our slope formula. So you have this already in your notes. It doesn't matter if I choose my first point to be x1, y1, or my second point. So I'm just going to label them like that. So let's plug in and find our slope. So we're going to take -1 minus 3 over -2 minus 0. We get -4 on top and -2 on bottom. Reminder that negative over a negative changes into a positive, and 4 divided by 2 is 2. Step 2 says follow the directions above or on the previous slide, or you can plug into point slope form, which we learned about last year in algebra. Point slope form, you can use either point to plug in, and we're going to use our slope that we just found. The plane y stays by itself, and I'm going to use my 3 from the y1 up there that's already been marked. We found our slope of 2, and then x minus our 0. I see parentheses, so I'm thinking right away distributive property. So now I have 2x, and then 2 times -0 turns into 0, so we don't need to write that again. So if we add 3 to both sides, we're going to find our equation is y equals 2x plus 3. Let's try and plug in that other point just to double check our work. You don't have to do this every time. I'm just going to prove to you that both points will work. So we're going to do y minus -1 equals 2 times x minus our -2. So minus and negative, we remember, turns into plus a positive. So now we have y plus 1 equals, don't forget our distributive property, 2x plus 4. To get rid of my plus 1, I'm going to minus 1. And so my equation is going to change into 2x plus 3. So y equals 2x plus 3 is our equation for this. And then our last step is to graph. So we're going to go up 3. And now we're thinking our slope is just a whole number. So if you just think of it as over 1, we're going to go up 2 and over 1, and that is going to give us our next points. Remember, I can use those negatives to get me points to the left. And I'm just going to continue along my whole graph. All right, draw your line. Don't forget those arrows. So now we've seen how to deal with if we're given a point and a y-intercept, a point and a slope, a point and y-intercept, or 2 points. So let's talk about these problems next. It says find the slope of the line that passes through the points -2, 6, and 5, 6. Then graph the line. So let's go ahead. We'll just mark this out as x1, y1, x2, y2. And we're going to go ahead and subtract. So we get 6 minus 6 on top, and 5 minus -2, which plus positive is going to change. We have 0 divided by 7. If you think back, 0 divided by anything is going to be 0. So our slope is 0. So let's go ahead and plug that into our equation. So plus b, we don't have a y-intercept, so we're just going to pick one of the 2 points. Again, it doesn't matter. So 6 equals 0 times -2 plus b. 0 times -2 turns to 0. So in this case, our 6 equals our b. So our equation for this line is going to just be y equals 6. So we can tell from this that I'm just going to have a point up at 6, so 1, 2, 3, 4, 5, and 6, and I have a 0 slope. So that makes this a horizontal line. So in the little box, all horizontal lines have the equation of y equals our y-intercept, which we know is y equals b. All right, so on the next problem, it says find the slope that passes through the points 5, 3, and 5, -4. So I want you guys to try that one on your own. We have talked about these slopes, and so we'll touch base with this problem tomorrow.